Okay, I hope you can hear me alright over the noise of the fan in my Instax power supply. So what I'm actually doing here, I'm trying to get an idea of how inaccurate the FNIRSI scope is, just so that, you know, anybody who's using this scope, and even, you know, taking into account, yes, it's just a sort of a hobbyist model, it's not really, you know, professional usage by any stretch. I certainly wouldn't, you know, recommend it for that, but for just the average hobbyist, you know, it's fine because of the inbuilt signal generator which we're getting for the cost, with a reasonable quality oscilloscope thrown in that does actually have even a base fast Fourier transform. I've actually got the coupling set to DC here, which you use the arrows for, and I'm on the 1x probe, and I've got the probes set up connected in conjunction with my a British Telecom multimeter set on the 200 volt range, because oh, there's the FFT line that's popped up, so that didn't go off. Let's get rid of that. It's still on. So the specs for this unit is it can only input a maximum of 40 volts into any of the probe, either of the two probe channels. That's 40 volts DC. Now I've got to double check it. I hope to do another test in future when I can rig up something, an AC signal, which I'm assuming, because it's 40 volts DC, it would only allow 40 volts peak to peak. So only 20 volts peak each side of an AC waveform, that you would be able to input this on a ×1 probe that comes with it, because, you know, that's the limitations of this scope. So from that point of view, if you want to be thinking about using this for mains, you would need 100 times probe, which I have actually just bought, and that's in the post. So I'm hoping to do another test with that when that arrives in a couple of weeks or whenever, and actually put it across the mains on the 100 times probe and see if I can actually get the actual waveform displayed with this unit. But if you do the calculations from the previous videos with the RMS multiplied by 1.414 for 240 volt peak, so 240 volt RMS here in the UK multiplied by 1.414, that's 339.5, nearest damn it, 339 volts peak value, and then of course you've got to double that for a peak to peak value. And as you can see, if you can see that, you would actually have a peak to peak voltage on 240 volt RMS here in the UK of 679 volts peak to peak. So even if you divided that with 100 times probe, you would then hopefully you would be able to see a 6.8 volts display and actually see the whole trace, because you can't do it with the 10 times probe, because obviously multiplying that by 10, which is what you'd view, you'd still have a peak to peak voltage even on the 10 times reduction probe setting, which is the little clip on the little switch on the side of your probe. If you've got a 1 and a 10 times probe, it reduces the input signal by 10, so you'd still see 67 volts, 67.8 volts peak to peak, which will not fit on the screen, which is why in the previous videos, before I'd had a chance to sort of think about and look at the scope, when I was on the I think it was, yeah, the old sort of the basket case Murphy, when I went across the primary windings of its transformer, it was off the scale, and also that's why when I measured the diodes, we got the top chopped off the yellow display, and it was only displaying part of the actual blue because of I hadn't put the rectifier capacitors in there to actually balance the DC and get them working more or less equally, which I did after. I didn't video it yet, and those diodes, they're only literally a couple of volts out on their DC peaks. So anyway, just to show the real world usage limitations of the FNIRSI 1014D, I've got my power supply set up across both channels, because it's a 30 volt per power supply unit. So I'm set to series mode with one of the buttons pressed in here, which puts it in series, in which case I'm going across both power supplies, which are joined then from this positives joined to this negative. Which you can just see my finger here. So they're actually, when you go into series mode, these actually join, and then the power supply is controllable by just the master knob here. So as you can see, I'm using my BT meter because it's the best quality and the most accurate one I have. Now, a couple of years ago when I had this supply, I actually calibrated this. There's a couple of little pots inside that you can calibrate the unit with for the LED display. So I calibrated it to my old British Telecom meter, which has since disappeared. I lent it to a friend and it's just disappeared off the face of the earth. But luckily I managed to find another one off eBay, which is actually in better condition. So let's assume that even despite their age, the BT unit, would have been good quality in the day. And as you can see, even going across here, I've got the display now is actually reading 20.1 volts on this display and 19.9 on this display. So although the two sides of the power supplies aren't exactly accurate, they are within 0.1 of a volt, and the two together add up to exactly 40 volts. And that is exactly what I'm reading on the BT scope. So these two I'm going to take as my references. Obviously I haven't got an industry standard reference to calibrate either of these two devices, but as it was previously done 2 years ago to this exact model of scope, for this level of accuracy, it's just to actually use it to point out the relative inaccuracies of the FNIRSI. Because what I'm actually reading now on the DC range, as you can see, if I wind the voltage down, this drops the actual DC reading down to 0. So at the bottom of the scope, although the numbers I am aware, obviously, that it's very blurry for you because I've got a crap camera, which I am looking at changing. This is actually climbing. It's on 10.8 volts now. So winding that back up to get exactly 40 volts on the meter, which is there. Again, got the 20.1 on one side, 19.9 on the other side. So I'm going to take it as the reference of 40 volts. This is now hit the top of the screen, and that's its limit. Unfortunately, the actual maximum voltage, which you can set your parameters here, what you want to read, you can set Vmax or VRMS and voltage peak to peak, and etc. So this is set to Vmax, and it's actually reading 38.9 volts when it's actually hit the top of the scale. And it's supposed to be a 40 volt input. So already you can see that the inaccuracies of the unit, and this has now had the version 3 firmware upgrade done to it. So as you can see, what it should be reading is 40 volts here, because that's its actual specifications for its maximum input before the signal goes off the screen, which means in this case the line just hits the top and won't go any further. But an AC wave, it means that obviously peaks out on the screen as well, and you get the top chopped off. If you had a wave going across the top, that gets cut, which is what we saw in that Murphy video when I was measuring the diodes and the mains input transformer. So what does that mean in terms of specification and accuracy? Alright, it's not a lot, but if you do the calculation, it's supposed to be 40 volts, it's reading 38.9, so it's actually 1.1 volts out across only 40 volts. So if you divide 1.1 by 40 volts and then multiply that by 100, you get a percentage error of 2.75 volts per 100 volts. So you've got a 2.75% inaccuracy, and that's obviously going to, if you're going to be reading much higher voltages than that on the 10 times scale, etc., you're going to start to get out of a sort of a reasonable range. So really, you're going to be looking at the visual indication roughly. You're not going to be using this for accurate voltage measurements, but it's just a hobbyist scope. So, for example, if we now changed the probe coupling to 10 times, Set that to OK. And now if I flick this probe to the 10 times scale, you see now it actually goes down to 36.8 volts. So now that's got a 3.2 volts inaccuracy. So 3.2 volts divided by, which would now be 400, sorry, divided by 40, so 3.2 volts divided by the 40 volt range that you're measuring on the 10 times probe scale gives us, and then multiply that by 100, that now gives us an 8% inaccuracy on a 10 times voltage scale. So, you know, although you'd now be able to read up to 400 volts at the probe on the 10 times setting, you could be reading down to 392 volts because it's got an 8% inaccuracy reading. So I just wanted to point that out, and also clarified, you know, because you want to know what you're actually working with within the limitations of your equipment that you're using. So I hope that kind of just gives an indication to people who have got this, who've done the version 3 firmware update, which is necessary to do, because before I did that, if you look back at the video that I did on the Murphy, when I before I'd done the firmware update, I was getting negative readings on reading an AC input and strange stuff like that. And also one of the consequences was that it didn't actually, if you switched from AC to DC coupling, it wouldn't actually show and be reflected in AC or DC sort of notification here either. So I just thought I'd put that out just so that I know what I'm doing with this scope and what its limitations are, and I hope that helps other people who have bought this unit and are wondering why, you know, how it can be so out if they did what I did and just went straight to try and say read AC mains, which I really don't recommend anybody doing, you know, using this unit to read AC mains unless you're really happy and know what you're doing, you know, and using a 100 times probe as well. But really, you know, I wouldn't risk making a mistake and overloading the input of this unit. It's just not built for that. You know, I mean, a normal oscilloscope, they're actually, I think the last analog one I had actually could handle a 400 volt input as an old analog unit, because obviously they were designed back then to you know, be used in conjunction, you know, with valve amplifiers and other things of that caliber. So you were dealing with 400 volt ranges, so they were designed to actually take 400 volts, certainly, you know, for DC, and probably AC as well, depending on the unit and that type of thing. So I hope that kind of clears up a couple of things on the FNIRSI for those who are using it, and kind of maybe clarifies some things for beginners on what you need to look out for, and to generally how to do a really basic level of comparison, calibration between, you know, a couple of known units or ones that you're going to be using as your main reference for the work that you're doing. So just to finish off, now that I'm on the 10 times probe, obviously now this is a 60 volt power supply maximum. So if I wind this up all the way, allowing for the inaccuracies of the actual two power supplies that are in this, you can see at maximum it reads 60.7 volts. That's the maximum DC voltage I would be able to apply to, you know, say like an amplifier, DC side of an amplifier board, which is really quite handy, because obviously a lot of them really usually only have a maximum of, say, plus and minus 30 volts if they're a split rail amplifier, say a class B. And as you can see, it's reading 58.7, which is so that's the maximum that I would be able to read on a DC range with a 10 times probe with this particular power supply. So obviously if I had a more powerful power supply, I should in principle be able to go up to near enough 400 volts using the 10 time probe if I had a 400 volt power supply, and get somewhere near the top. And obviously I can't do that, I don't have one. And then, you know, on 100 you'd want to be able to do that calculation again and see how far out the percentage, do that percentage calculation for its inaccuracy to see what the percentage difference is between what it should be reading and what it really is telling you on the Vmax scale here, which in this case is 58.7, when it's actually should be reading 60.7. So again, it's 2 volts out on 60. So if you did that calculation, you'd have 2 divided by 60 and then multiplied by 100, and now you've got 3.33% inaccuracy on a 60 volt DC input range. Okay, so I hope that helps you get perspective on what the limitations of the gear that you're working with